Hello everybody and welcome to the video. Today's video, all of the notes and the practice can be found on page 8 in your packet. We're going to be taking a look at a new concept called percent composition. Now before we do that, we do have to revisit a little concept of molar mass. Previously we discussed how to measure or to determine the mass of 1 mole of a compound, defined as the molar mass. And what we learned is that all of this information can be found from the periodic table. Essentially, you're given a formula like H2SO4, and using that formula, you can use the periodic table to determine the individual masses of the elements in the formula, and then add all those up to get your total mass. Now, what we're going to talk about today is, once you've determined a total mass, how can you determine what percent that each of these elements make up of that overall compound? And I'm sure some of you have a pretty good idea of how to do this, but we got to be thorough and make sure that we do talk about it. So that brings us to the concept or the topic of percent composition. Percent composition is defined as the relative amounts of elements in the compound, or the percent by mass that each element is or makes up in that compound. Percent composition has many applications in the world of chemistry and in many other worlds as well, not just chemistry. One of those is in the way of how fertilizers are designed. Depending on the season, the time of year, or even just the specific plant that you're trying to grow, different fertilizers are composed of different percent compositions of the key nutrients that plants need. Those nutrients are nitrogen, phosphorus, and potassium. And depending on what season it is, what you're growing, or a combination of both, you will need different percent compositions of each of these elements in your fertilizer to serve different purposes. For instance, we've got a different percent composition for lawn fertilizer that you would use in the summer versus fertilizers that you would use for planting things in your garden or shrubs or flowers, things like that. So percent composition is simply just the percent that each element makes up of an overall compound, and that's what we're going to be determining today. So to determine the percent composition from a chemical formula, it's really no different than determining the percent that you would get on a test or a quiz where you take your part or your total number that you got correct and dividing that by the whole or the total number that was possible on the test. So for us to determine the percent by mass of an element, we're going to use a pretty similar formula where we're going to have our mass of just the element in one of the elements in the formula divided by the mass of the overall compound. Then to get that into a percent, you're just going to multiply that by 100. Really hope that my screen didn't just go out for you guys like it did for me, but we're back. And then we're just going to multiply that by 100 to get our percent. So in this example here, we've got, we're going to be looking at the natural gas propane. And a lot of you probably have used propane for your grills. There's a lot of other applications for propane, but it has a formula C3H8. And what we're going to be asked to do is determine what percent carbon makes up in that C3H8, as well as what percent hydrogen makes up in that C3H8. So the first thing that we're going to want to do is determine the molar mass of the compound by using a periodic table. So if we want to determine the molar mass of C3H8 or propane, we would first take 3 carbons, 3 times 12.01, and then 8 hydrogens, 8 times 1.01, giving us an overall mass of 44.11. So this value is what we're going to be using in the denominator or the mass of our compound when trying to determine the percent of each carbon and hydrogen in the formula. So once you've done that, once you determine your total mass, we are going to take the part mass or the mass of each element to determine the percent. So for step 2 and 3, I've broken it down by first carbon. For the percent composition of carbon, we see that there are 3 carbons in the formula. We're going to multiply that by the total mass of 1 carbon. So 3 times 12.01, we're going to divide that by 44.11, multiply that by 100, and what we would find is that carbon in C3H8 makes up a percent composition of 81.8%. If we did the same thing for hydrogen now, using the 8 hydrogens, each of which has a mass of 1.01, and then we divide that by the total mass, 44.11, that we determined up here. Multiply that by 100. What we find is that hydrogen in C3H8 makes up a percent composition of 18.2%. So using the formula of the compound and finding the masses from the periodic table, we were able to determine that in propane, 81%, almost 82% of that is carbon, and 18.2% of that is hydrogen. Now notice both of these percentages add up to equal a total of 100%, which is always going to be our goal. And maybe that's a good way for you to check your work. If all of the percent compositions in the formula add up to be 100, then you probably have calculated things correctly and you're ready to move on. So I want to see what you guys can handle with a couple of practice problems. Again, this is really just a simple percent calculation, now utilizing concepts in chemistry. So I know that might take a little bit of practice, but I think we'll pick up on this quickly. So on page 8 in your packet, you have two practice problems, or two examples, calcium chloride, CaCl2, and lithium phosphate, Li3PO4. And I'm just going to ask that you find the percent composition of each of the elements that are in the formula. So if you want to, you can pause the video here, work on the two examples, and then I will go ahead and throw the solutions up so you can kind of check your work and see how you're doing with this concept and see if you need to come to class the next time I see you and ask me any questions or get any clarification. So press pause, do those problems, and then I'll show those solutions once you unpause it. So there is the solution for CaCl2. You see that our calcium makes up 36.11% of the overall formula, and the chlorine makes up 64.89% of the overall formula. Now here are the solutions for lithium phosphate, Li3PO4. We've got our total mass here. I've got the calculation for lithium, phosphorus, and oxygen as well. And then all of our percent compositions should add up to 100, or at least pretty close to 100. So that's it for today's video. Pretty straightforward, pretty short and sweet, just setting you guys up for some of the amazing things that we're going to actually be able to use percent composition for this week in class. Let me know if you guys have any questions, but I hope you enjoy the video, and I will talk to you soon.